Did you know that cephalopods are the most intelligent invertebrates? Their ingenuity and behavior have shown this multiple times. In some recorded instances, an octopus has snuck into a crab pot, eaten the crabs, and gotten out before an angry fisherman could pull the trap up. This is no easy task for the octopus. It included millions of years of evolution and generations of learned behavior. I'm Dale Bowerick.
I'm Nick Chomey.
And we're going to talk about cephalopods today. Cephalopods had to start somewhere, and originally they did not resemble the octopus we all know today. 500 million years ago, when cephalopods were first emerging, they still had shells that molluscs are known for. While there is still one cephalopod species that maintained the shell, the nautilus, most have foregone the tough external skeleton in favor of either an internal structure, like the Decapod, or replaced it with a hydrostatic skeleton, like the Octopodoformes. Cephalopods come in all shapes and sizes, from the 13-meter-long giant squid to the diminutive pygmy squid that only grows to 2 centimeters long. 500 million years ago, when cephalopods first emerged, they were the biggest animal on the planet. They were 9 meters long, straight, and conical. But even with these enormous sizes, they still only live 1 or 2 years as a rule. Cephalopods are the most incredible invertebrates just based off the number of niche roles they can fill. Some are ambush predators and others are detritivores. They fill every position no other organism was capable of. Class Cephalopoda is broken up into 5 orders: nautiloids, orthicone, ammonoids, decabranchia, and octopodoformes. They emerged in this order, making the oldest known cephalopod the nautilus, which is still around today. Nautiloids, orthicones, and ammonoids all maintained the molluscan shell, until with the exception of the nautiloids, they each went extinct. Decabranchia contains 2 superfamilies, the Cepioidea, or the cuttlefish, and the Teuthoidea, which includes all squid. Finally, there is the order Octopodoformes, which includes superfamily Vampyromorpha and Octopoda. Vampyromorpha only includes 1 species, and looks similar to an octopus or a squid. Octopoda is the superfamily of true octopuses. They all eject ink and change color. All cephalopods have one thing in common. They each have 1 head and many feet, hence the name head-foot or cephalopod. Some cephalopods convert their feet or tentacles into various types of receptors. Nautiloids, for example, convert one of their feet into a spadix, their reproductive organ. Nautiloids emerged roughly 500 million years ago. They are the most similar to the rest of the mollusks. They have a curled external shell, a lot like many mollusks. Unlike all other cephalopods, the nautiloids have 2 sets of gills, like the classic mollusk, unlike the rest of class Cephalopoda, which only have 1 set of 2 gills. Nautiloids have many tentacles. They have various uses for them. 1, they convert into a spadix, but most are used for tactile sensing and prey manipulation. Unlike other cephalopods, nautiloids have no suckers on any of their tentacles. This is likely because suckers didn't evolve until after nautiloids did. Nautiloids also don't have chromatophores, which many other cephalopods do. This seems pretty obvious why they don't, as they are covered in a shell. Why would they need to be able to change color? Unlike other cephalopods, nautiloids rely on physical protection from predation, with their shell rather than trickery like many other cephalopods. Nautiloids feed mostly on dead crustaceans, but will sometimes take on small live crabs as prey. They have chemoreceptors on their tentacles to alert them of nearby food and other environmental factors. Nautiloids can grow to be 8 to 10 inches in diameter. Their shell has over 30 chambers within, each connected by a siphuncle. They travel by jet propulsion, much like squids and octopus do. They travel to mate in warmer climates and lay eggs individually. A modified tentacle called the spadix transfers the sperm packet. It can take up to a year for an egg to hatch.
Orthocons emerged 480 million years ago and quickly went on to take over the oceans in a similar way to the sea scorpions. They could be massive. One fossil found was 9 meters long, with an opening on one side where the tentacles of the creature stuck out and a sharp point at the other end. They likely were able to swim very fast, but they were outcompeted by fish as they took over the oceans. Like the later cephalopods, these creatures likely grew very quickly, even growing their aragonite shell fast enough to reach 9 meters long in a few short years. Like the nautiloids, orthocones use their shells to help their buoyancy. The shell was broken up into internal airtight compartments that could increase or decrease their air pressure, letting them go up and down like in a submarine. In between these compartments, a hose called a siphuncle allowed air to transfer from one compartment to the next. Orthocones didn't make it while nautiloids did, most likely because of the shape of their shells and their size. Since orthocones were generally bigger than the modern-day nautilus, we can infer that the orthocones probably needed much more energy than a nautiloid. Add in fish competing for the same food, and the bigger orthocones have been outcompeted. But what about the little orthocones? They likely died out because of their pointy shell. Imagine trying to swim while carrying a long pipe attached to your head. It would not be a pretty swim compared to their nautiloid relatives. They were bulls in the water, capable of incredible speeds, but had a challenging time with sharp corners. Compared to swimming with a pipe sticking out of your head, swimming with a barrel on your back is much easier. Ammonoids emerged around 420 million years ago and have been extinct since around 66 million years ago. They had a similar body structure to nautiloids, including a tightly coiled shell, but the position of the siphuncle was different. Rather than running through the septa and camerae, the ammonoid siphuncle ran through the ventral side. Much like the orthocones, they are currently extinct, likely outcompeted by their nautiloid ancestors. The subphylum Decabranchia contains two orders, Sapioidea or cuttlefish, and Teuthoidea or squid. Cuttlefish are unique in that they have a hard internal shell called a cuttlebone, which aids in buoyancy through osmosis. The cuttlefish can vary how much air or water is in the cuttlebone and by extension how well it can sink or float. The cuttlebone is highly porous, very lightweight bone, responsible for keeping cuttlefish at the depth the cuttlefish wants to be. It is made up of 38 chambers built out of calcium and carbonate and B chitin. B chitin only makes up about 4% of the cuttlebone, but is incredibly important because it is more resistant to water than A chitin. This is because it is hydrophilic and holds water in between chains of glucosamine. This makes it so the fluids in the cuttlebone are hypotonic to the ocean. That means less salt and therefore more dense. This makes cuttlefish very easily able to stay at the same depth but needs slightly more energy to change depths. As they ascend through the water, the fluid in the cuttlebone becomes more hypertonic, and after 6 hours at a new depth, buoyancy is fully corrected. This ability is well suited to most cuttlefish life in a reef. All Sapioidea have 8 arms and 2 retractable tentacles used for catching prey. Cuttlefish are active predators. Their chromatophores in their skin change color as they begin to hunt. The hunt has 3 phases. Attention, where the cuttlefish sees prey and signals with its chromatophores its intent to hunt. Positioning, where the cuttlefish gets in the proper position using its cuttlebone to adjust for buoyancy and density. And seizure, in which the cuttlefish makes its move and captures its prey. Instead of a cuttlebone, squids have a flexible bottle-shaped structure called a pen. Much like sepioids, they have 8 arms and 2 tentacles with 4 rows of suckers surrounded by hooks for moving prey closer to their beaks. They have beaks that resemble a parrot's beak, which they use to slice their food up before they swallow. They vary greatly in size, but the largest, being the giant and colossal squids, are very rare to see. Squids will hunt in packs. called a shoal or a squad, such as the Humboldt squid. They come toward the surface from the deep sea to search for food. Using their hooked suckers, they pull prey in, such as fish, to eat. All octopodiformes have 8 legs connected to one head. With the exception of one species, they can all shoot ink and they can all change colors. Also, with the exception of subclass Vampyromorphida, they only reproduce once. This is because they don't want the issue of intergenerational competition. Order Vampyromorphida contains only one extant species and many extinct taxa. The vampire squid cannot change color or shoot ink, and is the only known octopodiform to lack these traits. Vampire squid eat primarily falling marine snow, a shower of organic material falling from the near surface into the depths. Vampire squid's 8 legs are all connected with a mesh of tissue, limiting their range of motion. They are capable of bioluminescence, which they'll do occasionally. This likely isn't to let them see, as they consume exclusively marine snow and they are not calling in prey. They use it for predator evasion. Since they can't shoot ink, they startle the predator with a bright light, and they're gone before the predator can react. All members of under the order Octopoda have 8 legs, can shoot ink, and change colors. Their ability to change color trumps all other animals with this ability. While other animals, such as chameleons, need prolonged exposure to blend in, octopuses can change color and texture of their entire bodies in an instant and hide just about anywhere. They are the most intelligent invertebrates of all time, practicing learned behavior, things we normally associate with mammals. For example, some octopuses have been known to hunt alongside partner fish, which they can direct by punching them to get them to go where the octopus wants them to. Other octopuses can hide in shells and pounce when ready, and others still will hide with camouflage, changing the color and texture of their skin to blend in with their surroundings. Some will grab onto clams or crabs and hold on for many hours, prying or breaking their prey open and eating their insides. In several ways, octopuses have displayed abilities and behaviors that scientists categorize as higher-order functions. In addition to the molluscan ganglia, octopods have other lobes and nervous centers, whose functions have been compared to the cerebellum and frontal lobe in vertebrates. Octopods have 3 dedicated nervous systems which operate mostly autonomously, interacting less with each other than within themselves. The central nervous system is composed of 64 lobes and around 40 to 45 million nerve cells and surrounds the esophagus. The eyes, or optic lobes, are their own system made up of 120 to 180 billion nerve cells, and they deal with vision. The arms have a nervous system of their own as well, made up of around 350 million nerve cells. Octopods are also able to very quickly change their skin color to match or respond to the environment around them, indicating a heightened awareness of their surroundings for the sake of catching prey and avoiding predation themselves. Octopuses also have displayed several behaviors that indicate more complex cognitive abilities. Scientists have tested octopuses by installing movable artificial landmarks and letting the octopus become accustomed to them. They would then move the landmarks while the octopus was out hunting, so the octopus would have to navigate back to its home without those landmarks. The octopus was quick to catch on and took note of landmarks that couldn't move because they are more reliable indicators of where it was going. Octopuses have also been observed moving rocks in front of their holes to block them off while they were away in order to prevent other animals from taking shelter in its spot. Octopuses are able to learn and store information and can be indicated by their adaptation to the changing landmarks, as well as other means of getting into small or closed-off spaces and use of different objects as tools to complete tasks. They've also been studied for different levels of play, which regards behaviors in which they interact with an object without putting it near their mouths. Different levels involved how much they pass an object between their arms, towing the object around for extended durations, and pulling or pushing the object around.
In conclusion, cephalopods are some of the most intelligent, resilient, and adaptable organisms on the face of the planet.